This video covers the idea of electric potential energy. So we have discussed gravitational potential energy before, and we found that the change in potential energy was equal to the work an agent does positioning the object. So for example, if an agent like this girl here does work to lift a ball above the ground, the work that she puts into the ball will give the ball a gravitational potential energy. We also know that like charges repel, so we can do work in positioning this positive charge closer to the larger positive charge. And if we put in 5 joules of work to position this positive charge, we could be asked the charge's change in potential energy. And like we said before, the amount of work an agent must do to position an object is equal to its change in potential energy. So since we put in 5 joules of work, we know that 5 joules will be the charge's change in potential energy. Let's say that we have a uniform electric field, and we know that positive charges will want to go with the electric field, or they feel a force in the same direction as the electric field. And negative charges want to go against the electric field, or they feel a force in the opposite direction as the electric field. So if we end up doing positive work on the charges, which will give them potential energy, we know that we must move them in such a way that they do not naturally want to go. Let's for a moment go back to our gravity example. If we let the ball fall, or essentially go where it naturally wants to go, we know that it will lose potential energy. And if we bring the ball in a position where it does not naturally want to go in, which is above the ground, we know that it will gain potential energy. This idea of moving an object where it does and does not want to go and how it will affect its potential energy is similar to charges. So if we bring a positive charge, if we bring a charge where it does not want to go, it's going to gain potential energy. And if we bring a charge where it does want to go, it's going to lose potential energy. So here we have a uniform electric field, and we know that positive charges want to go with the electric field and negative charges want to go against the electric field. So if we drag a positive charge from point A to point B, we are bringing it against the electric field, which is a direction that it does not want to travel in, so it's going to gain potential energy. If we drag the positive charge from point A to point B, we are bringing it with the electric field, which is the direction it does want to travel in, so it's going to lose potential energy. You can also think of an agent as doing negative work on the charge. Since it has to hold back the charge to let it slowly travel in the direction it wants to go, the agent then places a resistive force in the opposite direction as the displacement. And we know that if force and displacement are in opposite directions, the work is going to be negative. So if we drag a negative charge from point A to point C, we are bringing it with the electric field, which is the direction it does not want to travel in, so it's going to gain potential energy. And finally, if we drag a negative charge from point A to point B, we are bringing it against the electric field, which is the direction it wants to travel in. So the agent does positive or negative work positioning the object, and it loses potential energy. So let's do an example to see if you guys are following the ideas presented in this video. We have an electric field shown to the left with 3 different positions, and we want to know at which point would an electron have the least amount of potential energy. So we know that negative charges or electrons want to move against the electric field. So for this electron to have the least amount of potential energy, it has to be the closest to where it actually wants to go, which is at point A. We could also be asked at which point would a positive charge have the least amount of potential energy. So to have the least amount of potential energy, it has to be the closest to where it wants to go. And positive charges want to move with the electric field, so we know that a positive charge will have the least amount of potential energy at point C. Next, we could be asked, starting at point B, which point would a negative charge move to gain potential energy? So we know that negative charges want to move with the against the electric field lines. So in order for it to gain potential energy, it's going to have to move where it does not want to go, or against the electric field lines. So it's going to have to be at point C. And lastly, starting at point B, which point would a positive charge move to gain potential energy? So we know positive charges want to move with the electric field. To gain potential energy, it's going to have to go where it does not want to go or against the electric field. So that is going to be at point A.